Okay, let's start. API designs. Whenever you are using your mobile app, your laptop, generally lots of kind of data are displayed by your mobile or your browsers. So these data, these informations are requested data are come from the particular server. So generally, these are the your mobile apps, laptops, or browsers. These are the clients, and clients have not all these data. These data are come from the particular service provider which have already service deployed and somewhere on the internet. And our API are request via internet and get data from the internet. So generally, here all the data you view on your laptops or mobile apps, these are data served by some services. Maybe your system or maybe your applications or a software. That server software are deployed somewhere on the internet. By the internet, the communication happen and your browser, your mobiles displaying the data. So this communication generally nowadays happen with the help of API. So API is the one of uh, designs mechanism tools available where your client, that means your laptop, browser, mobile applications are communicate to the server, and server have provide those data. This is happened to the API. So generally, this API is not generally used to make a communication between your servers and this client. Even one application server or one software server system can communicate with another software system as well as. So you can say communication between the two are more software systems are software with the client maybe mobile user, maybe desktop user, maybe laptop user, any kind of users happen via API. The API can have a standard nowadays way through the communication between the device, between the system, between the software happen. So let's today talk about these API designs. What are the different way? What are the different types of communications channel available? And this API how help us while the system designing we have to expose API and the communication happen. What kind of a definition? What kind of a tools techniques these API offer us, right? So let's talk about the API designs. So what is the API? Before going to understand API design, let's understand the basic meanings of API designs. So API stand for Application Programming Interface. Interface just as a if one people's want to talk to another people, so they are going to talk via some interface. What are the interface? Interface is a language. Like I talk to you in the form of English language. The language become an interface between me and you. Similarly, in the computers, one software is talk to another software using some language, using some interface. So this is the programming language interface here. So API is the application programming language interface that is refer to the process of creating well structured, standardized, and documented interface that allow different software system communicate to each other. Here, maybe the software system 1, software system 2, they want to communicate. If they want to communicate, they need the clear one interface document so that the client should aware, hey, this is the way server can understand. Like you know a different language, I know the different language, how communication happen. So some intermediate interface required so that explain what you can understand and what I can understand. Similarly, this API documents are that is a well structured and standardized document available so that not only one machine, any kind of software system can make the communication between these systems. So here systems maybe software systems, microservices, module, service, application, anything that help us to communicate. So communication between the systems required the well standard, well structured, standardized document interface. That interface help us both server also understand about the client and client also understand about the server what kind of data, what kind of information they want to exchange as the communication. So these documents well defines which rules, which protocols, and which data format. Very, very important. Which data language, which data format client want, which so that the server can serve. Our server, what language, what format understand. Similarly, client send a request and server can respond. Because here, whatever the request sent by the client, understand with the first server. So what server understand the same things as a client send. Similarly, what response returned by the server, response is only returned by the server that's understood by the consumer. So here very mutual understanding required. First client send request to the server. Okay, server receive the request, but server must what server have a capability, what server know only those he can understand. So client must first aware what the server have a capability, what language, what data format server understand. The first he have to know those standard format. Accordingly, client send a request to the server and server then understand, hey, this is a well understand format. I understand what you want. Similarly, they can process the request and response back to you. Similarly, here, now client receive the data, but server how no client can understand. Similarly, server also required understanding how my response client can understand. Accordingly, they can prepare the response and send. So here, whenever communication happen between the client and the server, or server 1, server 2, they have well understand to each other what server understand and what client understand. This is known as a request and response. Okay, so these API designs are defined well standard standardized data format or document interface. The API design is nothing, just is the well structured, standardized document interface between the client and the server, or server to server. And that's exactly mentioned which rules, which protocol, what are the data format happen between the clients and server. Hope this information is clear. So let's talk about next some basics about the API designs. So whenever we talk about the API design, at that times we have to talk endpoints. What are the endpoints? Endpoint is specific URL that define the entry point for API request. Any requests come where this is the client, send a request. Where request goes? Client required one specific URL. What is the URL? URL contain the specific protocol. Hey, I'm going to the HTTP protocol. Okay, great. And this request go on which machine, which networks. So they specify our IP addresses or host name. Let's keep this is the IP, this is the machine where my request go. Right? And in this machine, couple of application is running on the different port. So you have specify, hey, this is the port, or this is the in this port, this is the application, and this is the resources. So URL contain the complete information about the protocol, about the IP address, about the port number, about the applications, about the specific resources, specific data you want. So this is known as specific URL. So that is exposed by your service provider. That is known as an endpoint. Means the client we are going to request and stop. That is the endpoint. Means that endpoint is specified by the specific URL. And that specific URL, my server, my application, my business logic is run. So this is sometime in the API designs, this done generally developer talk, hey, I am going to expose one REST endpoint, one GET endpoint, one POST endpoint. Endpoint means the complete specific URL so that client can access it. And whenever we are exposing any endpoints, we have to mention this what kind of action user wants. User want to perform get request, post request, put request, delete request. So a specific HTTP methods client must tell to the server, hey, this is a get request. That means our client are interested to getting data from the server. Client say, hey, this is the post request. Means I am submitting some my data. Please store in the server. Hey, I have a data. I want to modify something. Put. I want to remove some data, delete some data. So this is HTTP method be specific mentioned in the API designs. And whatever the communication established between the client and server, what the request and response should be. That means what the request client send so that server can understand the meaning of users, and similarly server's response back to the client so that client can understand the meaning. So client send request to the API and API respond data with a specific format, maybe basically JMS, JSON or XML. So you have a two format available. You can send request in a JSON format or XML format. Similarly, response can go to the JSON format or XML format. Whenever the decade back when the web service concept happened, the soap based web service implementation happened. At that time generally XML was the popular choice to send and receive request and response exchanging data. But nowadays due to the microservice architectural, lots of application building, they are using the JSON request and response format. So nowadays you can say API request and response format preferably would be the JSON, so that JSON request can be understood with the server, a JSON request can be understood with the client, so that the understanding between the client and server become so easy, right? So let's talk one plus additional things. Whenever particular server expose some endpoint 1, endpoint 2, endpoint 3, endpoint 4, that's good. Some endpoints are very public, means any client, any user, any browser can call and get data, there is no problem. But some endpoints I am designing for a specific client. If a specific client X and a specific client Y, X and this is the Z, this API is defined for X and Y. If X try to access, it's allowed. If Y try to Z try to access, it's not allowed. So somehow we have to apply the security. That means each API depend upon the use case. Some API required authentication and authorization. So our while designing API, we have to ensure that this API is required authentication. That means this API is designed for specific types of user, specific user, or specific user have a specific roles and permission. They have a proper authorization, then they can access. So these are the security layer of the each and every endpoints we have to decide depend upon the nature of business. Some are the public APIs, some are the non-public API. Some are the only authenticated API. Some are the authenticated plus authorized user. This if particular API accessed by the my employee, but they have a specific role. Maybe this is a manager, or this is the CTO, or this is the my HR. Only they can access. Other cannot access. So all the security parameter of each and every endpoint we have to decide. And similarly, whatever the data exchange happen between the client and server, that must be well formed so that there is no confusion happen between the reading and understanding the meanings of the data. And also API designs talk about the error handling. What happened? I am sending the request to the server. Somehow, due to some reasons, servers are failed to respond. Are they respond some error? So error is also would be very descriptive. Error handling is if in the response be clearly mention if I am responding successful, data come under the this section. If any error happen, the data come under the error section and error have a complete detailed message available. This whatever the user send a request, this request maybe is not required authentication or authorization. So be clearly mention, hey, this API required authentication. You are not valid user to access this API. Let's do valid authenticated user try to access the API and API through either, hey, you are not a authorized user to access these resources. Maybe you are a valid user, but you have not allowed role to access these resources. So be clearly mention error handling. Maybe some input validation fail, maybe some business logic fail, maybe some uh, business exceptions occur. So you can say while designing the API response, we clearly mention the success scenario, response data as customer expected, and also mention the failure scenario. If something failed happen, something unwanted error happen, client must receive the detailed error message. So our request is the contain everything and response contain success response as well as the failure response. Hey, my server down, some outage of memory, some infrastructure issues, some rule request validation error, or some business error message that happen. Any kind of everything defined under the error handling sections while the API designs. So these are basic uh, points or concept with the help of in the API designs. First is the endpoints. You have to define be clearly a specific URL so that customer can reach on your service and customer you tell mention is a specific HTTP methods like post, get, delete, and request response well documented, generally in the form of JSON. And similarly, your API, if required, some authentication, authorization, be clearly mentioned, and the data format would be clear, and error handling could be. So your response contain the data model, success data model, and the failure data model as well as so that the client be clear what kind of response is receiving from the server. Okay, so let's talk about benefits. Whenever we are designing our system with the help of API communications, so our system gets some benefits with this API design. First benefit is our loose coupling. API design promote loose coupling between the systems and allow greater flexibility and scalability. What do you mean by that? That means here you can build system of microservice 1, microservice 2, microservice 3, microservice 4, multiple microservices you are defined and they are communicated via the API gateway. API gateway are is called to the different microservice and this microservice required communication they can call another microservice this required to call another communication happen. So now independent microservice data required communication happen by API and now communication happen, then we can build separate microservice, separate microservice, separate microservice. Each microservice independently scale them and independently build them, independently test them. That is the scalability and flexibility, because we have to some modification, some change, some new requirement can just go to the specific microservice change, or one new microservice I can go easily integrate here. And if this required data communication happen between the different microservices, so this kind of loose coupling on demand communication between the one microservice to another microservice happen. This is possible due to the API designs. API design promote kind of a loose coupling, and this way our system reusability also going to work. Let's give you develop one same endpoint. Same endpoint can be used by the mobile user, can be used the desktop user, can be used the laptop user, can be used by the third party server. So same code can be reused by the API designs, and even API designs are very specific for resources. So our faster development means specific API you develop, test independently, and delivered to the production for testing. So independent API, independent module, independent development testing happen, because these are the specific resources, specific requirement, and that may help us to develop faster. Well, faster means you develop quickly and reach the your API to the customer environment, to production environment. Okay, and that also improve the our skill security part, because now you have clearly defined which API is the public API, which API is the non-public API, which API require the authentication, which API require the authentication plus authorization, which API are only allow for the admin, which API allow for my all employee. Be resources labor, you are apply your security guidelines checks available. That's promote improve our security at the each and every resource layer, right? So let's talk about how to develop API and what types of API. And nowadays, dozens of options available for the system design engineer to develop API. Like you can develop REST API, gRPC API, GraphQL API, SOAP API, WebSocket API, Webhook API, MQTT API, Server Sentiment API, OData API, OpenAPI. Even this list is go on and on. I have just summarized little bit. So as a system design engineer, our responsibility, we have to be carefully know lots of options we have, and each approaches to designing API have a some weakness and some strong point, some advantage, some disadvantage, and each API have a different context, different way, different situation you can use. Some API might be synchronous communication, some API might be asynchronous communication, some API might be unidirectional, some API might be required the bidirectional, some API may be notifications, some API. So because our application, our system have a different nature of communication required. So depend upon nature of my system collaboration, system communications, we are going to develop different API. So I'm going to talk very little, very basics about this API, but these each approach to API designs is required detailed discussion. The each and every API have a well standard architectures and framework and basic concept behind that we have to understand and implement. So good option. As for today, I'm going to just brief about these are the different approaches for to developing the API, And whenever you have to choose anyone at that time while the development, we have to understand deep and detailed architecture of the each approaches, how you are going to the build, what are the syntax, semantic, framework, technology available for that. So I'm going to just brief these some types of API, but it is the very brief, not even complete definition, you can say. So let's talk about the REST. Meaning the representational state transfer is the REST API. And REST API is the one of the architectural style for designing a application communicate over internet to the another application. One application can communicate to another application over the internet. The objective of the REST API is designed to communicate one software system to another software system. This is not designs for the customer can directly view, because this is the not so readable format for the end user or customer or normal user. The first thing, the this REST API is designed for the application to application communication, or front end communication to the back end communication, or you can say mobile communication to the server communication, a client server communication. Client, not the user. Client would be another front end applications, mobile application, right thing. So this is the scenario where REST communication happens, REST API implementation happens. A good example, Twitter have a and lots of industries are using REST API. And the good things, whenever you talk about the RESTful API, these are very specific for HTTP methods. Maybe one API for the get, one API for the post, put, delete. Because the get HTTP methods are very standard. Get for the getting some content or data from the server. Put means ki I want to update some information. Or post, hey, client want to save data in the servers, and maybe some delete requests. So be specific methods you have to define for the REST API. That's the REST are most popular API designs nowadays approaches. Many microservice applications are going to use to design API with the help of REST approach, REST architecture style. Sometimes we are talking about the gRPC API. So generally, gRPC API is the high performance gRPC RPC framework, remote procedure call framework that allow efficient communication between the services. That means this is a very design key. One specific microservice talk to another specific microservice. That communication happen between the RPC protocol, remote procedure call, where the particular gRPC API, gRPC server are deployed the gRPC service on a particular port, and clients are reading data from the specific port. So somehow this is a very kind of high performance RPC framework. On top of that, this gRPC API develop, and that make efficient communication between the microservices. Not this is not more popular like our front end application going to the call gRPC API, or our mobile application called the gRPC API. This is generally our one microservice, maybe payment microservice, maybe product microservice, maybe inventory microservice, maybe notification microservice. They are in generally communicate between through the gRPC API, because this work on the RPC frameworks. And Google Cloud API is expose these kind of gRPC API. A gRPC API is the work under the, you can say, different concept, like maybe here you mentioned this is the protocol protobuf file. So while developing gRPC API, whatever the gRPC server provider, they are writing one protobuf file. Protobuf file we have specified, hey, this is my service, and service, what is the request parameter, what is the my response parameter, we have to mention, and also mention request message, what the details of request, what is the response message, what is the response, and these are complete in the protobuf file, and protobuf file is compiled, and accordingly our server expose the particular implement the services, and similarly client are going to consume the services. So they have some standard protobuf syntax we have to follow to develop the gRPC API, but these are also one of the popular API designs communication channel available between the microservices or between the services, you can say, right? Similarly, one of the approach by the GraphQL API designs. GraphQL API designs look like the query language for API. Let's see. This is the my we have a expose one API. This is one API. Customer calls and we customer get these huge response. So customer is not interested to all the data. Why not customer call this API? I say in this API I want only name address. So our API has only return the specific data which want. So here's a GraphQL is a query language for API that allow client to specify exactly what data they need. So here, GraphQL look like a query language, like SQL for the getting specific data from the database. Similarly, GraphQL is the query language for the API. Generally, here we expose one single endpoints, and that handle all the queries, maybe get name or get name and address, get name address and phone number. These are the different query you can do for the API. So GraphQL is the also one of the approach where client exactly what data they want from the API, they can do query on the API. Uh, Similarly, we have a very popular SOAP-based web services. You can say decade year backs, whenever the microservices, not the services concept come, monolith initially monolith application, then modular, then service-based application. Whenever service-based designs come, at that time service communication happen. Yeah, how one service are communicate to another service at that time. This is a simple SOAP is a protocol, simple object access protocol designed for exchanging structured information. That structured information generally in XML format, those means XML data are travel on the internet for the well-defined format. So at that time, the web services were developed for the SOAP API, and the requirement was that SOAP is the very specific protocol to exchanging data information between the web services, and these web services are used specifically XML based annotation and data. For implementing SOAP, again we have to write one well standard document. This is known as a WSDL, Web Service Description Language, where mention our service, complete URL port, and then particular request, port, binding, message, every message detail, everything we mention, and this was consumed by the client to understand how I can access this. They can develop one SOAP message, and all the data, XML data are travel between the on the net internet protocol and the SOAP envelope. So these are the very specific API, SOAP API. These are little bit you can say compared to the rest or gRPC, the very complex you can say. These are still many places SOAP API are used where our business logic is so complex and you want to kind of very secure and complex enterprise level applications where the SOAP API are still used. right? So SOAP use the XML to define the interface, and payload format they use the HTTP or other protocol like a SOAP protocol to communicate over the internet. And similarly, nowadays we have a WebSocket API design as well. So WebSocket is a protocol that allow bidirectional real-time communication between the client and server. So whatever the client, whatever the server, they want the bidirectional communication and the real times. So this is the way this WebSocket API also help. Facebook exposed the web service WebSocket API. WebSocket API use the persistent connection and that allow real-time communication. So here WebSocket say, hey, this is the one socket, WebSocket open for a specific client, and the communication happen. And another, they until this communication going on, they channels are very persistent. Okay, the connections very reliable communication happen, and the real-time communication happen. You can say. And sometimes nowadays all the IoT devices the device that generating continuous data, maybe temperature data, weather data, like maybe log data, security data, continuous sensor data. So these data are going to communicate to the services. So for that, we can use MQTT API. Is a very lightweight messaging protocol that is designed for the some IoT devices. And these are the good example. Lots of IBM. What's it's an IoT API available. This is the concept of the publish subscriber model. Means our we have a publish means whenever data publish that can be consumed by the multiple consumer kind of things, the publish subscriber, and where the communication generally happen like asynchronous manner. So these are the not IoT devices not sending data and waiting for the response. Just send data, send data, send. Let's they are going to the wait. Lots of messages going to the queue because they are devices that continuous generating data, continuous receiving data from the actual devices. So objective is that the asynchronous communication happen. So in those scenario, MQTT API you can designs and build, right? So let's talk about some different tip. So okay, so generally whenever you build application, you are most probably building system that's send client send data to the server and server respond, hey, this is the my data. But there are some approach where our server itself I just send an event to the our client. That is known as a server event server send event API, SSC API. The SSC is a kind of a protocol that allows server push event to the client. The such way you can use such scenario where your client need the notification needs push event from the server. So those scenario server send event API you can design, and Google's already have example for that, and they still use the persistent connection to allow real-time communication for the clients between the server. Nowadays, for any real-time notification kind of things like hey, all the payment industry, let's say I'm going to the pay start payment. So if the particular payment received by the payment service provider, payment is started going on pending success or failure, such real-time notification I want to give to the client. So such scenario Webhook is a protocol that allows server to send notification to the clients, and this Webhook API is a callback function like things. We have to register, hey, this is my request and this is my callback function. And once you done, just update all your status change in the particular clients. So these are also nowadays Webhook are used by the GitHub, lots of API, Webhook API, many places like your payment system, third party payment processing, where our clients want to get notification of actual work happening. Maybe delivery systems where the customer need the actual notification what happened, my system is delivered, what are the tracking systems, notification systems, where you can Webhook API you can design, where you want give the real notification of the activities which is going on for the customer initiated, right? Sometimes you can also think about the OData API, Open Data Protocol API, is the protocol that allow creation and consumption of the RESTful API. So how to RESTful API can you consume or send? Microsoft Azure have the standard protocol used for the open. Similarly, nowadays, very common terminology going on the Open API. Open API is just like a formally a Swagger, because the whenever you are building API or you are not integrating the Open API, Swagger API, client which are they are going to consume your API, a tested API, they are very hard. So this Open API help us as a Swagger help us to make a standard URL, standard request, standard response. Open API also allow from the browser or a customer or client can verify them, can test them. I think it's a very standard documentation nowadays. Whatever the API you are going to the build RESTful API. So RESTful API, how that is known, how client know, hey, this is a RESTful API. So this Open API, yes, Swagger API nowadays mostly popular way is a protocol kind of things that allow to create RESTful API and consumes RESTful API. And nowadays, the Amazon Web Services also offer the Open API documentation. Open API just integrate. This is a very simple. If you are using a string or any just give us some library, just integrate in your applications. Your applications Open API expose the well documented API for you, and you can just go and test through this. The Open API is a very standardized for the RESTful API consumptions and creation. So these are all of I'm not discuss everything, but this is the lots of things for the API design. But before discussing any one of them, you have to understand which scenario where these API are used. And if you understand and later part you can go deep dive the specific approach to designs your API, right? So let's talk about the REST. REST is the whenever you are building API that is quite simple, standardized way of accessing and manipulate resources. Where resources might be customer, user, payment, order, inventory, product. These are the basic simple you want to create, update, delete. So REST is the very good way you can start building the API. Okay, but somehow you are inter microservice communication you want to very high performance API that required very low latency and high throughput. In this case you can go with the gRPC. And similarly, like a GraphQL, you can building API that's required more flexible and dynamic query for the customer. Let's tell the customer what kind of data and the particular data schema you want. Let's you carry yourself. We are not going to develop dozens of API for you. Just I develop one single API, you hit them, and what the data you want. Let's tell them those API. Those API are response specific data what the query want to do. So this is also one of the very unique way to design say API. Not build dozens of API to you and customer know I have to call this API, I have to call to this API, I have to call this API for this purpose, this API for this purpose. Instead, GraphQL say, hey, let's expose one single API. You call them, and what the data you want in those schema, just tell the query, ask the query. That means GraphQL is a SQL query language for a API. You are just querying on the API. Similarly, SOAP-based applications well defining the standardize the standard, well structures, secure data exchange you want to between the services. In those scenario, enterprise application, very highly secure applications nowadays still all the secure, very customized, complex nature of data you want to travel between the microservices, between the services, you can use the SOAP-based API and SOAP-based API as well as. Similarly, WebSocket, whenever you want to build a real-time API that require the bidirectional communication, you can go with the WebSocket. And any sensor data, IoT data communication, you want very lightweight and efficient communication between the huge kind of events communication happen, publish subscriber model happen, you can go with a MQTT based API. Similarly, sometime want, hey, our server give the real time event to the our client, you can go with a server sent event kind of API. And any kind of real times notifications to the customer initiated transactions, you want to tell, hey, customer, start the payment processing, payment is received, payment is going on, payment is in progress, payment is success, or payment is failure, something our callback taken care by the notification. The webhook is designed such a way your callback or async notification between the clients and server happen. And lots of, you can say, even the basically famously use the open source API, where you want to expose all the details about the request response, HTTP method, what are the URL, everything to the customer, to the clients. Let's expose the open API yes, so you got documentation, so that you don't worry about the separately communicate, separately tell them, hey, client, this is the standard, my all the REST API, this is my request, this is my model, this is my response, what kind of a data type, what kind of value. This open API or Swagger will publish all your endpoints to the customers. So all the things, this is a very brief about the different API design approach. But my suggestion, this is just for FYE. These are the different approach, different use case, different situation, different context for those different communication happen. So you have to be carefully choose you are going to make communications via synchronous or asynchronous or unidirectional or bidirectional or batch processing or bulk processing. Accordingly, we have to event notification based, real time, bidirectional, what is your use case. Accordingly, you have to choose the communication channel, different kind of API designs approaches, nature of your requirement, you have to choose this API designs approach. A good part, lots of technology available here to help us to design the API. So one of the challenges whenever you have developed lots of API, you have dozens of microservices. Each microservices expose dozens of API. So this is very hard for our client application, front end application, UI application to find out where microservice deployed, what the instances are due to the scalability issue. Multiple instances of the same microservice are exposed. That's are very hard to manage API. Due to that, we have to use the API management platform. One of the best things, we have to apply the load balancer or API gateway that's distribute your load to the specific requested microservice. So lots of tools available. You can use the APG or AWS API gateway, Azure API management, Google, even lots of open source API gateway available, even commercial API gateway available. Because whenever we are designing lots of API, this is very hard to clients. So for the managing client, smooth communication between the server and the client only possible with a API management tool. Else, customer client is very frustrated to find out your application URL, port, everything, right? So please think API management platform, maybe open source or commercial cloud provided API gateways. And whenever you are going to design API, you have to choose the programming language, because nowadays almost every programming language allow you can build the API. Okay, you can use the Java language, .NET language, Python language, Node.js language, JavaScripting language, even the Go language, any other lots of language which allow us. Hey, you can design API using this programming language. The nature of be aware, lots of programming language offer this API designs approach. And even the on the top of this API programming language, we have a lots of framework available. Let's say Java have a lots of framework available that help us. You can design API. That's Spring framework, Quarkus framework. On the using Java programming language, you can build the REST API using a Spring Boot or using the Quarkus in different approaches. So we have to also, for quick and fast development, generally nowadays the system design engineer is choose a specific framework on the specific technology, specific programming language. Okay, these frameworks are help us, our system design engineer, they can very quickly, like a Spring Boot, very quickly within a limited time frame you can develop API. Lots of infrastructure, protocol, standard, everything taken care by your framework. So let's use the existing market framework available. And even lots of API, you have to also choose the proper API tool, because API can be test independently. So you can use a Postman, you can use a SOAP UI, you can use a JMeter, you can use a Swagger, you can use the OpenAPI documentation to testing and validating API. And even you can perform lots of security validation, request validation, response validation. So you can say, please be carefully select technology for your API designs and development. API management tools, programming language, framework, and your testing tool. All these help us. You can build a system that is very flexible and scalable. The objective is that we can deliver a system that's are more highly available, flexible, and fault tolerance available, consistency available. All these happen if you are building a system in the modular microservice based architecture. Whenever you are building microservice based architectures, your services are need to communicate to each other. This communication happen by the API, and API is the efficient way to communicate between the services or communicate between the my front end application or my mobile application. So API is help us to establish communication, data exchange between front end application to the back end application to the different server, between the microservices, maybe and different third party service communication happen. So lots of communication happen. That's help us with the API designs. In API designs, if you are follow the well rules and principle, your API, once you designs, your application become the very loose couple and increase the reusability, increase the security parameter, and they meet the flexibility and scalability. So all these parameters, you can say API designs promote. So these are the basic key requirements of system designs. So hope this information is helpful for you. Thank you for the day.